You have spent 3 days preparing a simulation dataset on your local machine. Now you need to move 2 terabytes of input data to the HPC cluster before your compute allocation starts. You open a terminal, type the copy command you have always used, and a progress bar appears. 30 seconds later, you do the math. At this rate, the transfer will take 11 hours. Your job starts in 4. The problem is not your network connection. The problem is the tool you chose. Different file transfer tools on HPC systems can differ by a factor of 10 or more in real-world throughput for identical data over identical connections. Today I am walking you through every method, explaining exactly why they perform differently, and giving you the decision framework to pick the right tool every time. Before choosing a file transfer tool, you need to understand the storage architecture of a typical HPC cluster, because that architecture determines where your data needs to go and what physical path it takes when it arrives. A standard HPC cluster has 4 distinct storage areas, and each one is designed for a different purpose. The first is your home directory. This is a persistent, backed up file system with a relatively small quota, typically between 10 and 100 gigabytes. It is intended for configuration files, environment scripts, and source code. It is not designed for large datasets, and many clusters enforce quotas aggressively to protect it. The second is the project or group allocation. This is a shared file system with a larger quota, sometimes several terabytes, allocated to a research group or project. Long-term data that multiple team members need to access lives here. The third is scratch storage. This is a high-performance parallel file system, typically implemented as Lustre or GPFS, with very high sustained throughput but no redundancy and automatic file purging after a defined retention period, usually between 30 and 90 days. Any large input or output data for an active job should live here, because the parallel file system delivers the bandwidth your compute nodes need to run efficiently. The fourth is the data transfer node. Most modern HPC centers provide one or more login nodes specifically configured for data movement, separate from the interactive login nodes used for job submission. These nodes have dedicated high-bandwidth connections and are specifically tuned for transfer performance. You should always initiate large transfers from a designated data transfer node rather than a general login node, because general login nodes may throttle or kill transfer processes that consume significant CPU or memory.